Welcome to the first word problem on the chain rule that we're going to look at. This involves van der Waals equation from chemistry that says a gas occupying volume V at a temperature T exerts a pressure P according to this equation. So P plus A over V squared times V minus B is KT for constants A, B, and K. And we want to compute the following rates of change. Rate of change of volume with respect to temperature, and the rate of change of pressure with respect to volume. So this is just going to be dV dt and dP dV for part B. So we'll go ahead and look at this. So there's a few ways to do that. One is to solve for V, then take the derivative with respect to t. But we also have this other trick that we saw where we can define a function in terms of P, V, and t, and then use this equation. dV dt is negative partial of f with respect to t over partial of f with respect to v. So we saw that little trick last time. So I'm going to do that. I'm going to move this kt over to the other side. So I have this stuff equals 0. And then I can go ahead and set my function equal to all that. And then it equals a constant. And now I can use this as my function f. So that's what I'll use as my function f. So now to compute this dV dt, we'll just take these partials right here. So the partial of f with respect to t, that's going to be a negative k, because all this is constant, no t's at all, and then derivative of negative kt, just negative k. Partial with respect to v is a little bit harder. That we're going to need a product rule. So I have this in terms of v, that in terms of v. So we'll go ahead and do derivative of the first. So that's 0 plus a times v to the negative 2 would be a negative 2a times v to the negative 3. So that's what I get for my first term, times the second, v minus b, plus the first times derivative of the second. So derivative of this second term, just derivative of v, which is 1. So now we got all that, we'll go ahead and simplify it a little bit. So I can multiply the v and the minus b through this first term here. So I get negative 2a. V to the negative 3 times v just leaves me with v to the negative 2. So there's v to the negative 2. And the negative b times the negative 2 gives me a positive 2ba times v to the negative 3. So that's what I get for that term. And then 1 times that second term just leaves us with the second term. P plus av to the negative 2. Alright. We can also combine this negative 2av to the negative 2 with this other av to the negative 2. So one of those minus two of those gives me negative av to the negative 2 plus the rest of the stuff. 2ab v to the negative 3 and plus the p. Alright, so there's my partial with respect to v. So it's sitting right there. Alright. Now what we can look at is putting both of these pieces together. So if we put both of these pieces together, let's see what we have. So this is going to be dV dt equals that partial of f with respect to t, so av to the negative 2 plus 2abv to the negative 3. So that was our partial with respect to v. And now negative times negative is positive. So I get positive, and I can multiply top and bottom by v cubed. So if I do that, I just get kv cubed, and all my negative exponents are going to go away on this bottom one. So v cubed times v to the negative 3, that's 1. So we're just left with 2ab. V cubed times v to the negative 2, that's just v. So we get minus av for that term. And then p times v cubed. So there's my final answer. Kv cubed over pv cubed minus av plus 2ab. Alright, let's go ahead and tackle that second one. So the second one's going to be a little bit easier because we already have most of the work done. We need the partial, or the derivative of partial of f with respect to v over partial of f with respect to p. And so I already have the s of v, so I'll go ahead and use that in a minute. But the partial of f with e minus b times a p, but then the rest of this is just other constants. So this constant times that p derivative is just that constant, v minus b. So we'll go ahead and plug our stuff in. So that partial of f with respect to v goes on top. Partial of f with respect to p, the v minus b goes on bottom. And then again multiply top and bottom by v cubed. So we get the v cubed in the bottom. The other is just the same as that denominator up there. So there's my final answer.